Today we will learn how to calculate NDVI from or any other index using GE. So for that, first we have to import a study area or a shapefile that we have already imported into GE. So for that, first we have to import this shapefile, and we have renamed this shapefile as AOI for flexibly using this parameter for calculating NDVI. And now we are importing the data that from where we can calculate the NDVI. For that, we have created a variable named Landsat 8, and the function that we are using is e.imageCollection, which can read and import a set of image collection that is required for calculating any indices. So we are selecting this e.imageCollection, and after selecting this function or after writing this function, now we have to write the code of the data which we can obtain from the Google Earth Engine data catalog function, which I will discuss in a different video. So we are using Landsat 8 collection 2 tier 1 level 1 data, which has surface reflectance information. And after importing these data, now we have to filter this data for reducing the amount of data. So first we will filter this data using the filter bound function, which can reduce the data for your specific given study area. So we are using .filter bound, and we are giving the name of the variables, that is AOI, which we have already imported into the platform. So after that, we are reducing this data by date. So if we want to calculate the NDVI for a specific time, then we can use .filter date function, and then we can define the starting date within a single inverted comma, and following a comma we can put the end date. So we are using 2023 from 1st January to 2023 31st December. So we are using the Landsat images that are collected for this study area, defined study area, between 1st January 2023 to 31st December 2023. Then we are sorting this data based on a specific parameter which can be obtained from the metadata function. So we are taking the cloud cover percentage as the reducing parameter or for sorting the data, and after that we are identifying the least amount of cloud cover data using .fast function. So these are the code that we can use for reduce the amount of image for the study area for a specific time, and using a specific parameters of the images. Now we are importing the specific bands. So for that, we are creating a variable called NIR, and because we want to import the NIR band, and then first we have to mention the name of the data that we have already mentioned, and then if we put .select, that will select individual band from that collection of data and or the collection of images. So after that, we are creating another variables that is called red. Because we are using only NIR and red band, we are using the same function Landsat 8.select to get the specific band. If you want to import other bands, then you can use this function, and if you have to only change the name of the band, that we can also found from the image Google Earth Engine image catalog, Google Earth Engine data catalog platform. So after importing or defining these two variables, now we can calculate NDVI. So we are again defining a variables named NDVI, and then we are putting the equation. So the first equation is NIR subtracted by red and this function will be divided by NIR plus red. So this is the actual formula for calculating NDVI. That means NIR minus red divided by NIR plus red. So now we have to close this function by renaming the variables which will be used for displaying the calculated NDVI. Now we have to create another variable for providing the parameters that will be used for displaying the data. So now we are creating a variable named NDVI params, and for this function we have to define several parameters. So the first parameter is the minimum value of the calculated indices that we have put as 0, and then we have to define the maximum value which we are using as 1. Then the next parameters that we have to put is the color function that we want to place for the values of NDVI indices. So we are starting with blue, then white, and then green. So the lower value will be represented by blue, middle value will be represented by white, and the higher value will be represented by green color. Now we have to close, or we have to end this piece of function or this piece of code for displaying the NDVI that we have that we will calculate using this platform using Landsat satellite imageries. Now if we want to calculate or run this function and if we want to display these images, first we have to define the center point for which area we are trying to display these indices. So the function will be map.centerObject, and the center object will be the shapefile that we have imported, that is AOI. And after defining the center object, we have to define the level of zoom. We are using 7 as the level of zooming. And after that we have to display the NDVI. For that we are using the function map.addLayer, and within a bracket we are providing the name of the data that we want to display and the parameter variable that we have created for displaying different properties of the calculated parameter. And then we are providing a name which will be used for displaying in the legend. So after that, if we click on this run, it will automatically run all the code and it will calculate the NDVI for our defining study area. So it is calculated, and now the task is to export this map into our Google Drive. So for that we have to use this export.image to drive function, because this function will export the image into our Google Drive. So after providing this function, we have to define the image that we want to export. So the image is NDVI that we have calculated. Now we have to define description. We have to provide a description or name of the data that will be used for exporting, providing the name of this exporting indices. Next, we have to define a scale, that is the pixel size, and we have provided 30 meter because the Landsat pixel is 30 meter. Then we have to define the region for which it will be the data will be exported, and that is AOI. And the last function that we have to provide is max pixel. That means maximum how many pixel will be exported. So we are providing 1E13, and then we have to end this code by providing a semicolon. And if we click on this run button, it will automatically calculate the index, and it will be asked to export the image from tux function. So if we click on this run function, it is showing a error, and this error is coming because we have put a space between the name. So if we use a underscore or any other function, then it will not be difficult. So after that, it is not showing any kind of error, and we have to provide the name of a folder where the data will be exported, and if we click on this run, it will be exported into that folder. And if we don't put any name of the folder, then it will be directly exported into the Google Drive platform. So in this way, we can calculate NDVI. If we want to calculate any other indices, then only if we can change this band name, then it will be it will calculate a different indices. And if you want to change the name instead of NDVI, if you can put the name of the indices that you want